Very good evening, everyone. All of you, please do confirm to me in the chat if I'm both visible as well as clearly audible.
Yes, sir. You are visible and audible.
Thank you so much, Indarama. Good evening, everyone. Right, I think I have waited for quite a long time for everybody to join. I don't think so. Waiting even a single minute more would be justifying to the students who have joined on time. Perfect. Let's quickly get started with today's technical discussion. Gurudev, I'm also equally excited as you are for today's session. So that's good to know. Also, I believe throughout the weekend, starting from Friday evening, or some of you, of course, have colleges on Saturday also. Basically, in the weekend, you have definitely invested your entire time in terms of revision and you have not wasted a single minute. Is what I'm going to assume. I know I might be wrong in many of the cases here, but there is nothing wrong in being optimistic about life. Anyways, so let's get started then. Right, a quick summary of the last class. In the last class, majority of the discussion was primarily with respect to the historical background of the Java programming language. That is what we have been able to understand. And I remember by the time I was concluding the class, I have also been able to shed light on the different versions of Java. The Java versions also we have been able to understand. Of course, as we speak today, the latest version of Java, it happens to be Java 21. I think it has been released just one week or 10 days before. And the next version of Java, it is going to be called as Java 22, and it is going to be released in the month of March of the next year, 2024. That is what we have discussed it in the last class. Right, now let us quickly get started. Priya, it will just be a waste of time for others if I would repeat the versions of Java once again. I would suggest please go log into the LMS and please watch the recorded session of the last class. I think that would be a better use of time. Perfect. And I had also told you, if anybody would ask you, what are the most important features of Java? What is your answer going to be? I want all of you to quickly respond. Do not become lazy in terms of responding. You're not losing anything. What are the most important features of Java? Now I'm getting just one feature as an answer from all of you. I am using the word as a plural here, features. Undoubtedly, 100% Java happens to be a platform independent programming language. The most important feature it is. Along with that, it is also an object-oriented programming language. It is freely available. And of course, under Sun Microsystems, it was open source. But as we speak today, it is going to be owned by Oracle Corporation. And under Oracle, it is no more open source. It has been made as closed source software product. Perfect. Now, for you to understand the very first feature now, that is what is going to be the point of discussion today. Before that, there are a few prerequisites with respect to the memory of a computer. I don't want to assume that you already know and then start directly discussing platform independency. But just because you lack your sufficient understanding about memory organization of a computer, I don't want any lacuna in terms of understanding the platform independency feature of Java. So first, I would like to check box the prerequisite for you to understand this topic, which is nothing but the memory organization of a computer. Within our computer, how are the memory devices organized? How are they going to communicate? Where is the data going to be stored? How is the data going to be fetched? All of this information is what I would like to first speak about. Perfect. So let's quickly get started. Let me just share the screen. And I hope the last session's paint window is not closed in my computer. Yes, I found it. Perfect. I believe the screen is visible for all of you. Let me just clear the screen. Now, see, what are we going to be discussing, sir? Like I said, we are going to be discussing the memory organization of a computer. And when I'm sharing the screen, okay, I'll just keep the chat window over here so that your messages are also visible for me. Perfect. Let's continue the discussion now. Now, see, which is the most important component within a computer? If anybody would ask you this question, what is going to be your answer? It is extremely important for all of you to be as active as possible. Your interaction is directly proportional to the understanding that you're going to gain. Okay, good. All of you have told processing unit, processor, the CPU, good. No, some of you are telling memory. No, which is the most important component within your computer? I'm referring to the hardware device here. Undoubtedly, it is nothing but your CPU. In other words, it can also be called as a microprocessor. So see, observe this, everyone. What is it you're trying to do, sir? What am I trying to do here is, this itself is a microprocessor. I'm going to call it as CPU, or it can also be called as microprocessor, but I don't have Greek alphabets on my keyboard. So basically it is mu p. I hope all of you know there is a symbol, mu symbol. So that is how it should be written as. Anyways, and about this device, long back we have understood the fundamental things about this particular component here. We understand your microprocessor happens to be a semiconductor technology device. That means the technology on which this device has been built, it is a semiconductor technology device. The semiconductor technology device. Perfect. Since it is a semiconductor technology device, all of you know this microprocessor is going to understand only two things. It can either understand a 0 or it can understand a 1. Apart from these two characters, these two alphabets, it is not going to understand anything. And the reason behind this, already, that is what I have spoken about it in my first class. Day 1, that is what I have been able to speak. So see, that is what I'm going to mention it here. This microprocessor is going to understand nothing but only zeros and ones. That is what it is going to understand. Perfect, sir. Next word, sir. Next word means, now I have a quick question for all of you. What is the job of this microprocessor? I'm telling it is a most important component within my computer. But like I said, what am I asking here is, just a second. Right, perfect. The most important component within our computer system, undoubtedly, it is the microprocessor or the CPU. But the bigger question here is, what is the job of this component? That is what I would like to understand here. Process the data, okay. Process management, processing data and give the output. Okay, all hi-fi technical jargons is what I see in my chat here. Produce the output, execution of instructions. Vinaya, very precise. Jyotirmai executes the program. Good. Ritya, to perform operations, processing. Okay, memory management. Okay, that is one of the responsibilities, but I'm asking the primary responsibility of this component. It is used to convert human readable language to binary language. Okay, after which, what are you going to do, Yashvita, with it? Great. After conversion, what is that can be done? Data management, execution of instructions. Okay. Convert to the code. Okay. I appreciate those of you who are acknowledging to my questions here. Thank you so much for that. Now, please understand this. The primary responsibility of this component is very simple. It is to execute the programs. That is why we have something called as the microprocessor. It is going to execute the program. Now, I have a quick question once again for all of you. All of this already in the previous classes I've spoken about it. Can anybody define here what is a program? I see that there are 400 participants in today's session. I'm expecting at least nothing less than 300 responses here. What is a program? I've spoken about it on the first day of my class. Okay, good. Set of instructions is what is referred to as a program. Perfect. To perform a specific task. Very good, very precise. Good. Right. Now observe this. This is what you're referring to as a program. Now let us say, this is my program over here. What is this program, sir? It is nothing but set of instructions. So let us say there are few instructions within this program. Maybe first instruction, second instruction, third instruction, fourth instruction, like this. Maybe this might be the last instruction within my program. How many instructions can be present, sir? That also I've clarified it on the first day itself. There is absolutely no upper limit in terms of the number of instructions that can be present within your program. You can have any number of instructions. Oh, great, sir. Next what, sir? Next what means this is my program here. See, this is my program. Now, can you tell me what am I supposed to do with this program? It should be executed. With the help of which device am I supposed to execute this program? Clearly, it is the job of your microprocessor to execute this program. But I don't know if you're able to see the gap here. I can't have this program somewhere in the air and directly I can't catch it and I can't throw it towards the microprocessor and the microprocessor is not going to execute it. Unfortunately, this is not another Marvel series or the Iron Man movie here. If you want this program to be executed, it cannot be present somewhere in the atmosphere. It should definitely be present in the same system where the microprocessor is also present, which is nothing but your computer system. That is why for the very first time, these computer scientists realized it is not just important to have a processing device within our computer. For that processing device to process the data, to process the instructions, the data and instructions should be stored somewhere on the computer. That means there is a need for a storage device within a computer. And when did this realization come to the computer scientists, sir? For the first time in the decade of 1950s is when they realized, boss, not only the processing device should be sufficient within a computer, along with that, it is also important to have a storage device within a computer. That is why for the very first time, observe this, all of you, all of these are very basics. But like I said, I want to keep everything clear in my classes. That is my style of teaching. Understand this. In the decade of 1950s, for the very first time, they invented a memory device. And see, this is how the memory device used to look like. Sir, what is this memory device going to be called as, sir? Understand this. This memory device is what we technically refer to as the hard disk drive. I'm sure all of you have heard of hard disks within your computer. That is what I'm referring to. And when was this memory device invented? Like I said, in the decade of 1950s. Sir, we want to know precisely in which year. To be very precise, it was invented in the year 1956 by a very famous company, a company that you and I aspire to work for, which is nothing but IBM. It was IBM in the year 1956 introduced this memory device technically called as the hard disk drive, nothing but your HDD. Great, sir. Next what, sir? Next what means, now, definitely you have a storage device, but this is a different device. Your microprocessor is a different device. If the data and the instructions from the hard disk should be executed by the microprocessor, if they have to flow and it should be reaching the microprocessor, definitely there should be some connecting medium between these two components. That is why, what did they do, sir? They have taken both of these devices and they have connected both of these devices with each other. How did they connect, sir? This is how they have connected it. Observe this. They have taken the hard disk and they have taken the microprocessor, and both of these devices, they connected with each other like this. Please do not forget, everyone, those of you who are not paying attention to this class, I have already reminded the last week. This week, somewhere in between, you are going to have a surprise quiz. So everything that would be discussed till the previous class of the day when the surprise quiz is going to be conducted is going to be asked. So You don't want to miss out on any of the information, then you shouldn't be regretting during the quiz. So please, I would request all of you to please pay attention. Hardly I'm asking your commitment for 30 hours, and that too, it is going to be for your career, it is for your betterment. And if you're such a lazy person, a lethargic person in life who can't commit to 30 hours in life, then I don't think so anything great you will be able to achieve. Anyways, with that being said, like I said, the hard disk and the microprocessor is going to be connected with each other. Sir, what is this connection called as, this connecting medium called as? In computer science terminology, this is technically referred to as the bus connection. Bus means I'm not referring to the public transportation that is there in your cities. Bus here means, in computer science terminology, it is not a single wire. It is a collection of many wires put together. That is what is technically referred to as a bus connection. I don't know how many of you have ever got a chance to open the CPU cabinet. And if you have seen, especially on your motherboard also, different devices would be connected with each other. But it is not a single wire. There will be at least 4 or 5 wires together. That connection is technically called as the bus connection. Am I clear with this, everyone? Right, perfect. Now observe this. Next, what is going to happen, sir? Whatever program that is residing on the hard disk, now if that program has to be executed, this is how the execution is going to happen. All of you should clearly pay attention here. The first instruction from the hard disk is going to be taken, and slowly it is going to flow through the bus connection. Slowly and slowly it is going to flow through the bus connection. And the moment it reaches the microprocessor, observe this. The moment it reaches the microprocessor, within a fraction of a second, the microprocessor is going to execute it and it is going to produce the output. I repeat once again, it is not even going to take 1 second. Just imagine it is going to take fraction of a second. If this is fraction of a second, just imagine how fast the instructions are going to be executed. So the moment the instruction reaches the microprocessor, that particular instruction is going to be executed. But hold on, my program is not yet completely executed. It was only the first instruction that was executed. Next, what is going to happen, sir? The second instruction is going to be fetched from the program. That is going to flow through the bus connection. Slowly and slowly and slowly it is going to flow. And the moment it reaches the microprocessor, once again, in fraction of a second, nanoseconds, milliseconds, that is how much time the microprocessor needs to execute that instruction. Extremely fast executing device your microprocessor is. Next, what happens, sir? Once again, the third instruction would be taken. Slowly and slowly and slowly it is going to flow through the bus connection. The moment it reaches the microprocessor, once again, in a fraction of a second, that instruction is executed. And for that instruction, whatever output has to be produced, that also is going to be produced. Great, sir. Next word, sir. I don't know how many of you are noticing it here. Intentionally, I'm emphasizing a lot on this word called as slowly and slowly here. The instruction from the hard disk is going to slowly and slowly move through the bus connection. And the moment it reaches the microprocessor, immediately it is going to be executed. Fraction of a second execution. Why is that, if you ask me? Now, please understand, your microprocessor is extremely fast executing device, but your hard disk compared to microprocessor is a very slow executing device. If you ask me the reason why, the reason is very simple. Why your microprocessor is fast in execution? It is because of the technology using which it has been built. Can you tell me what is the technology on which your microprocessor has been built? Semiconductor technology device. Semiconductor technology devices, by nature itself, they are very fast in execution. But when it comes to your hard disk, my friends, your hard disk isn't a semiconductor technology device. It is a electromechanical technology device. It's an electromechanical device. Sir, it is an electromechanical device. What is the technology on which it has been built, sir? Basically, it is also magnetic storage device. I don't know how many of you have seen it. Whenever you open the hard disk, do you see those rotatory disks within your hard disk? And there would also be a needle. above the rotatory disk. It is through that needle read-write operation is going to be performed. Again, I don't want to get into the nitty-gritties of the hardware details here. Just remember, your hard disk is an electromechanical device. There are also mechanical components that are going to be involved, and it is a natural law. Whenever there are mechanical components involved, obviously the speed of execution is going to reduce. Sir, so what, sir? What is your problem? I don't have any problem. Just try to understand this scenario here. Whenever within a computer system, the technology between two devices mismatch, the overall speed and efficiency of the entire computer system is going to be as fast as the slowest executing device within your computer. Sir, we didn't really understand the technical phrase, whatever you spoke about. Can you repeat it once again? Yes, I'm going to repeat it once again. Try to listen to it carefully. Whenever within a computer system, the technology between two devices mismatch, in that case, the overall speed and efficiency of the entire computer system is going to be as fast as the slowest executing device within your computer, not the fast executing device within your computer. What do you mean to say, sir? See, I think once I give a proper analogy, then if I make this statement, you'll understand it better. I once again give the disclaimer here. It is just my example here. It is just an analogy here. Don't take it to literal terms. Let us say all of you had this childhood dream. All of you had this childhood dream that you wanted to own a Ferrari car. That is a childhood dream that all of you wanted. All of you had. Now, obviously, you know, it is a very expensive car. So you have waited a lot in your life and you made sure that you're going to have a very stable career. And if you get into maybe some hardcore product-based companies and as a maybe full stack developer, as a software engineer, once you start working in a company, now let's say after your graduation, you have got into some product-based company and you have been working very hard in that company. Over a period of years, you have been climbing the ladder of the hierarchy, and finally you have become the CEO of the company. And you're almost 35, 37 years old now. And now you feel that you have everything in life. There is nothing that you have any more aspirations for. But now you feel, I think now it is time for my childhood dream to become a reality. I think it is time that I should gift myself something. Because see, usually the concept of gifts is you have to give to somebody else and somebody else is going to give to yourself, which is wrong. I believe it is wrong. You can also gift yourself and just try once at least in a while. You'll really feel happy about it. Anyways, so coming back to our story, finally you feel that you have everything in life and now you can afford to own a Ferrari car. And I'm sure all of you are also aware of this fact that you will not be able to purchase a Ferrari car in India. I mean, you will not get a Ferrari car directly available in India. It should be imported from Italy or Germany through one of the car dealers in India. So let's say in Bangalore, there is a car dealer, maybe in MG Road, and you happen to go to that person. Maybe you ask that person that, look, I wish to own a Ferrari car. So please make sure all the formalities are done and tell me how much it is going to cost. So all of the document verification, all of the formalities wherein all you have to sign, everything is completed. He is going to tell you, look, sir, as you're aware, Ferrari cars are not made in India. It should be imported from Italy. So it is going to take a lot of time. So you can expect your car to be delivered in 6 months. Now, you also don't have any option. You can't fly to Italy and you can't fly the Ferrari car once again back to India. It is not possible. You have to wait, need to have patience. Finally, you went back to work and you were continuing your regular routine life. And one fine day, suddenly in the morning, you get a call from that car dealer. Sir, congratulations. Your Ferrari car has finally landed in our showroom. You can please come and collect the delivery of your car. You are very excited. You immediately call your assistant and you ask that person to cancel all of the meetings, all of the appointments that you have for that particular day. Immediately, you start running towards that car showroom. You, in fact, come out of your office and you directly start running in the road. You forget that you want to go drive the Ferrari car, but you already have maybe BMW, Audi, which is parked in your parking lot. But you forget, you're so excited about it. After a while, you're so tired, exhausted, running. You finally take an auto rickshaw and you happen to go that car showroom. And in front of the car showroom, you have come to purchase a Ferrari car, but you're getting down from an auto rickshaw. Nothing can be done. That is how your excitement is. And immediately you walk into the car showroom and you're very excited. That person, the car dealer, is already ready with the garland and with that big key, car key made up of the cardboard box. It is ready. You're like, look, brother, all of that, you please keep it aside. I first want to see my car. I first want to drive my childhood dream, the Ferrari car. That person also understands your excitement. He immediately takes you to the place where the car is going to be parked. Obviously, it is been wrapped with the car cover, but from the external view itself, you're able to see the aerodynamic shape of the Ferrari car. Now you are even more excited. And now, intentionally, the manager wants to play around with you. He knows that you're very excited, so he is also trying to have fun with you. Immediately, he's not going to unravel the Ferrari car. Slowly and slowly, he's revealing the car. Slowly, he's unraveling the car cover. And while he's slowly unraveling the car cover, you have the tears of joy in your eyes. You're so excited about it. And the moment the car is unraveled, the car cover is removed, all of the emotions that you are going through, the emotions of happiness, excitement, joy, the emotions of fulfillment, everything, all of these emotions suddenly have converted into the emotions of anger, the emotions of anxiety. You're getting very furious. You might ask me, suddenly, what went wrong, sir? The moment car cover was taken off, you see that, in fact, the manager is also shocked. The dealer is also shocked. Somebody, while the car was being imported from Italy to India, on the way, somebody have detached the Ferrari car mag wheels and they have attached the bullock cart wheels to the Ferrari car. I know it is a bit of an exaggeration, but trust me, this analogy is important. Now you're extremely angry. Now you please think an answer. If you get a Ferrari car, I mean, this car has one of the best designed engines ever by the human kind. Now you will take that Ferrari car out of the car showroom, MG Road. It is a straight stretch of at least 7 to 8 kilometers. Now, do you think you will be able to drive the Ferrari car? The max speed of the Ferrari car is 340 kilometers per hour. That is how much the speed of the car is. The engine is same, best engine ever. Maybe the horsepower of the engine happens to be around 1800 horsepower. Wonderful design engine of the Ferrari car. That is what most of the price of the car goes to because of the design of the engine. Great, the engine is still there, but what you don't have is the supporting wheels. You don't have the mag wheels. What you have is the bullock cart wheels. Now you please think an answer to this question. At what speed do you think you will be able to drive this Ferrari car, which has got bullock cart wheels? Do you think you'll be able to drive this Ferrari car to its maximum speed of 340 kilometers? Forget about 340 kilometers. You might not even be able to drive this Ferrari car with a speed of 40 kilometers per hour also. Why? But the engine is same, right? Good. That is what I was trying to explain. Sir, how is this going to be relevant to our concept today? Understand this, everyone. Look at my screen. This microprocessor that you see, this is your Ferrari car engine. This hard disk that you see here, these are your bullock cart wheels. Now you please think and answer, how fast can you drive the Ferrari car? As fast as the bullock cart wheels are going to support the speed. That is what I also told you. Within a computer system, whenever the technology between two devices mismatch, the overall speed and efficiency of the entire computer system is going to be as fast as the slowest executing device within a computer. And in this case, it is your hard disk. Did you people understand whatever I've spoken so far? Great, sir. Next what, sir? Next what means the computer scientists were extremely disappointed. Hey, we have invested billions of dollars of rupees, years of research in terms of creating such a powerful device, which we refer to as the microprocessor. But unfortunately, because of the supporting device, the hard disk, we are not able to utilize the actual potential of this processing device, the microprocessor. So you please think and answer. With whom is the fault with? Just because you have the bullock cart wheels, will you take out the Ferrari car engine and will you put some Maruti 800 car engine within the car? That is a foolish way of analyzing the situation here. What you are supposed to do is you should remove those bullock cart wheels, once again reattach the Ferrari car wheels. That is going to solve the problem here. That means in this context also, the problem is not with the microprocessor. The problem here is going to be with the the problem here is with the hard disk. So what did they do, sir? Very simple. They decided, look, this hard disk is a waste device. Can you tell me what are the disadvantages of hard disk? First and foremost, it is a very slow executing device. Secondly, with respect to the size also, it is a bulky memory device. It is going to occupy a lot of space. And lastly, it is also going to be a noise. It is a bit noisy whenever you try to perform any operations on the hard disk. Slightly, it is going to produce noise. Why, sir? Because there are mechanical components involved in it. Sometimes you will see that the rotatory disks within your hard disk are making sound. That is what I'm trying to tell you. Because of all of these three limitations, immediately computer scientists realize, hey, this is a waste piece of memory that we have created. Immediately, it should be discarded from the computer system. You see, observe this. That is what they did. They immediately took out this hard disk from the computer system and they throw it in some corner of their research room. Just 1 second, observe this. Perfect. Next, what happened, sir? Next, what happened? Immediately, they went back to research as to how can we create a best possible memory device. Finally, it took them exactly 10 years. In the next decade, in the decade of 1960s, once again by the same company itself, IBM, in 1956, like I said, exactly 10 decades. This time it is going to be 1966. They invented a memory device. Observe this, all of you. They invented a memory device. Sir, what is this device going to be called as, sir? Forget about what it is going to be called as. Can you think and answer what would be the technology of this device? Are the computer scientists once again going to make the same mistake of creating this memory device with some other technology other than semiconductor technology? 100% no, because that is the ultimate reason for the entire problem here. Whenever the technology between two devices mismatch, so they have to ensure this time it is not going to mismatch. In other words, what would be the technology of this device? Absolutely correct. All of you are absolutely correct. It is a semiconductor technology device. Great, sir. Next word, sir. Next what means, sir, what is this device called as, sir? This device is technically referred to as the random access memory, nothing but the RAM of your computer. So what is the technology on which your RAM has been manufactured, has been built? It is nothing but a semiconductor technology device. Perfect, sir. Next what, sir? Next what means, understand this. Now, whatever data previously they used to place it on the hard disk. See, observe this. Whatever data previously they used to place it on the hard disk, now they are going to place the data on the RAM. The same data now is going to be placed on the RAM like this. Great, sir. Next word, sir. Next word means obviously, if this data should be processed, if the instructions have to be processed, the RAM and the microprocessor have to be connected with each other. How are they going to be connected, sir? Using the same connection, the bus connection. So observe this. This time, the RAM and the microprocessor are going to be connected with each other like this. Perfect, sir. Next what, sir? Next what means obviously the instructions from the RAM this time are not going to flow slowly through the bus connection. They're going to flow at extremely fast pace, and they're also going to be executed by the microprocessor in much more faster pace. So 100%, the problem of slow execution is 100% definitely been sorted. That means, what are the advantages of RAM, sir? Everybody started praising this memory device. A wonderful invention. What a best invention the mankind has made. So observe this. What are the advantages? Can you tell me what are the advantages? Of course, the very first advantages, it is fast would be an understatement here. It is extremely fast in execution. Next word, sir. RAM, it is not going to occupy a lot of space. Compared to hard disk, it is not bulky, it is compact in size. So see, that is the second advantage. And there are not going to be any mechanical components, any disks, needles and all involved here. It is a pure semiconductor technology device. That is why it is also not going to produce any noise. So no noisy. That is what I'm going to tell. Am I clear with this, everyone? So do you see that all of the three disadvantages of hard disk have clearly been overcome by the memory device called as RAM? Great, sir. Next, what happened, sir? When everybody was going gaga about this memory device, RAM is a wonderful memory device. It is fast in nature. It is compact. It is working with the speed of the microprocessor. Wonderful. It is just a matter of time that people realized that what they're praising to be the best invention of mankind with respect to the storage device also has got few limitations. What limitations are you talking about, sir? Some of you already know what am I trying to speak here. This RAM, see, look at this, has a small expectation. What is that expectation, sir? You will be able to store the data on this memory device called as RAM as long as one condition is going to be satisfied. What is that one condition, sir? That one criteria is 24/7. 24/7 electricity supply has to be provided. If there are any electronic students, don't think I'm grounding RAM, because I know this is the symbol for grounded. But what am I trying to highlight here is 24/7 electricity supply has to be provided. Even for a fraction of a second, look at this, everyone. Even for a fraction of a second, if the power supply is cut, gone. Doesn't matter how many GBs of data you have on the RAM. All of those GBs of data is immediately going to be erased. It is going to be vanished. This is a huge disadvantage. Now, what is this nature referred to as, sir? This nature of RAM, of course, this is a biggest limitation, biggest disadvantage here. Understand this? We call this feature as the volatile nature of a memory device. Volatile means you will be able to hold on to the data as long as the electricity supply is provided. The moment you cut the electricity supply, the data is going to be erased. I'm sure all of you, especially I think during your school days, in your chemistry classes, somewhere whenever the petroleum fuels and liquids lesson was being taught to you, it was told to you that petroleum liquids are volatile in nature. That is why today also, whenever you want to fill fuel to your vehicles, you don't always keep the cap of the petrol engine or diesel engine open. The moment it is going to be filled, immediately you have to close it. What would happen if you keep it open? Let's say you fill your entire tank. You keep it open. Good. All of that fuel that you have, it is going to be evaporated into the air. So, sir, are you telling data in the RAM will be evaporated? Hey, here, how will the concept of evaporation be applied? Both of them are technically referred to as the volatile nature here. Oh, great, sir. We understood, sir. Next word, sir. Next word means, sir, does RAM have any other disadvantages? Absolutely, yes. Compared to hard disk, even today also, RAM is a very expensive memory device. I don't know how many of you have noticed this. There is a place in Bangalore. It's called SP Road. If you have 4,000 rupees in pocket, if you go to SP Road, maybe For 4,000 rupees, it is possible that you might get 1 TB of hard disk, 1 terabyte. 1 terabyte means 1024 GBs of hard disk. But with the same 4,000 rupees, you will get just 4 GB of RAM. Are you understanding? 1024 GBs of hard disk, but just 4 GBs of RAM for the same price. So who is more expensive here? Undoubtedly, RAMs are expensive in nature. That itself is the second disadvantage of RAM. So observe this. I'm going to mention the second disadvantage here. They're expensive. Next what, sir? Not only this, tell me, within your computers also, or within your mobile phone itself, all of you are using mobile phones and most of you are also using computers also. Think and answer. Between hard disk and RAM, who do you think is going to provide you more storage capacity? Between hard disk and RAM, who do you think is going to provide you more storage capacity? I'm telling you, I'm expecting responses from all of you here. At the end of the training, if the certificate is not issued, please do not have the audacity to come back and ask why. It would be because of these reasons. Because the moment the webinar is going to be ended here, when I click on the end webinar button here, all of your chats are also going to be saved here. Between hard disk and RAM, who do you think is going to provide more storage capacity? Don't overthink. Just have a look at your mobile phone itself. In your mobile phone also, you have the internal storage, basically another name for hard disk. You also have the RAM. What is your internal storage? I don't know about you. For me, in my mobile phone, I think I have got 256 GB of hard disk and just 8 GB of RAM. Clearly, hard disks provide more storage capacity compared to RAM. That itself is going to be a third limitation here. Observe this. That is what I'm going to tell here. Less storage capacity. Are you guys understanding so far? Oh, great, sir. Next, what happened, sir? Finally, the computer scientists, they realized, look, boss, it is not possible to invent a single memory device that can satisfy all of the 6 expectations from a memory device. What are your 6 expectations, sir? It should be fast, it should be compact, it should not produce any noise, it should be a non-volatile memory device, it should be cheap, it should also provide more storage capacity. Is it possible to achieve through a single memory device? 100% no. That is when they started to think to reconsider the hard disk, which they had thrown into a dustbin literally. That is why they brought back the hard disk to their tables and they started analyzing what could be the advantages of hard disk. Now understand this. I want to jot down all of the advantages of hard disk. Now, if you ask me, sir, whatever data we store on hard disk, is it going to be stored temporarily or permanently? On hard disk, the data is going to be stored permanently. Why, sir? Because it doesn't always need electricity supply. I told you, internally, it is a magnetic storage device. That is why sometimes it is also called as magnetic disks. It uses both the principles of electricity and magnetism to store the data. So even when you don't supply electricity, it is absolutely okay. In other words, this is referred to as a non-volatile memory device. What about the price, sir? I already gave you the comparison. 1024 GBs, 4,000 rupees. 4 GBs, 4,000 rupees. So definitely it is inexpensive. What about the storage capacity? I don't even have to tell you. In my mobile phone itself, 256 GB of hard disk, but just 8 GB of RAM. Definitely, it is going to provide more storage capacity. I hope clearly you're understanding. In total, as a computer user, how many expectations do I have from the memory device of my computer, from the storage device of my computer? 6 expectations. But do you have even a single memory device that can satisfy all of the 6 expectations that I have? 100% we don't have even a single memory device. Is that clear, everyone? That is when they realized they felt really bad for discarding hard disk previously. They brought back the hard disk into the computer system. And How are they going to connect, sir? Are they going to connect hard disk once again with the microprocessor? Why will they commit the same mistake once again? You will go back to square one. So what very intelligently they did was they have simply realized, look, whatever data that you want, don't store it on the RAM because it is a temporary storage device. You take the data and please store it on the hard disk. And whenever it is needed, this data should be brought onto the RAM. It should be executed, faster execution. So what they have did is very smartly, they have taken the hard disk and they have taken the RAM and they have connected both of these memory devices together like this, once again through the bus connection. So in other words, if you are asked this question in the interviews, who is hard disk connected to? Hard disk is not directly connected to the processor. It is in fact connected to the RAM, and RAM in turn is connected to the microprocessor. Is that clear, everyone, so far? Perfect. Next what, sir? Next what means, like I said, always, where is the data by default going to be stored within our computer? That is how the operating system has been programmed. Whenever, in fact, from the internet also, see, let us say this is from the internet. Whenever you happen to download anything from the internet, is it going to ask you, do you want to store it on hard disk or RAM? By default, it is going to be stored on the hard disk. Directly, it would be stored on the hard disk. Now, let us say, okay, I think here also you'll understand better with this scenario. Let's say that all of you are working on your final year project reports. Now, you would have downloaded some template from the internet that this is how the project report has to be. Now, once you download it, it has been downloaded on the hard disk of your computer. Every day, you don't need to download it. But it is just a sample template that you have downloaded. Now, in that template, you have to fill the information specific to your project. Tell me, if it is only on the hard disk, will you be able to modify? Will you be able to write? You will not even be able to see that sample also. Why? Because, see, understand that this fundamental thing here. Even if you want to open an image in your computer and you want to see your beautiful selfie image onto your computer, that also cannot be done without the help of the microprocessor. If you want to watch a movie within your computer, courtesy of microprocessor. If you want to open the notepad and type the alphabet A in the notepad, and if you're able to see it on your screen, that also is the courtesy of the microprocessor within your computer. Basically, just remember this golden statement. Anything and everything within a computer, whatever you're doing it, it is all because of the microprocessor. It could be seeing something, it could be reading something, it could be writing something, it could be doing anything. You want to open paint, draw a circle there. That also is because of the courtesy of the microprocessor. So now think and answer. You have downloaded the template from the internet. It is there on the hard disk. You want to see how the template looks like. Do you think it will be possible only if it is on the hard disk? 100% no. Why, sir? Because you think and answer. Is the microprocessor connected to the hard disk? Look at the diagram here. 100% no. Who is the microprocessor connected to? It is connected to the RAM. That is why now if you want to open the template, let us say, from the internet, you downloaded some data. Where is it going to be downloaded by default? On the hard disk. Now, if you want to see this data, you want to change it, you want to do whatever you want to, it cannot be done only if it is residing on the hard disk. Definitely, it should be brought onto the RAM. So what is going to happen, sir? Immediately, the operating system, see, look at this, everyone. The operating system is going to take a copy of this data and it is going to place that copied data onto the RAM like this. So see, this is that copied data, whatever I'm talking about. And once it comes to the RAM, is the RAM connected to the microprocessor? Yes. Now the data is going to be processed. Whatever changes you want to do, you can do it. Is it clear, everyone? Okay, I'll better show this practically. Then I think it is going to make more sense. Are you able to see my Chrome screen here? Perfect. Now observe this. Let us say I want to download a sample text file. Some random text file is what I want to download. Okay, some file I don't even know. Okay, I'll close the ad. It has opened in the browser. Also, if you noticed it here, I have got the notification here. I think the file is downloaded. If I would, okay. See, did it even ask me where do you want to download Zabi? Is it on the hard disk or RAM? 100% no. Sir, where is it downloaded, sir? I think it's better I share my entire screen. See, I'll go to the downloads folder here and we'll try downloading it once again. See, now it is downloaded. I'll go to the folder. As you can see, it is directly in downloads. And now, see, whatever this sample 3, let me do one thing. I'll cut it from here. I'll better paste it on the desktop over here. Now, see, this is a file that I have downloaded from the internet. It is directly on the hard disk. I want to see what data is there in this file. Tell me, it is on the hard disk. Is anybody able to see what is there in sample3.txt? 100% no. If I have to see it, what is it I should be doing it? Hey, I'm not asking any rocket science question here. I'm asking, I want to see whatever is there in sample 3. We have to open the file. Okay. Double click. Okay. Okay. By clicking. Good. Double click. Open the file. Okay. Whatever all of you are answering, you're all absolutely correct. Basically, what you're trying to tell me here is, sir, sample 3, see, assume this is only a sample3.txt file. As of now, where is it? It is on the hard disk. Now, if you want to open it, I told you, opening it, seeing what text is there in this file, that also is going to be because of the microprocessor. And who is microprocessor connected to? Is that device connected to hard disk or RAM? Is it only connected to RAM? So what is that I should be doing? I should take a copy of this data from the hard disk and I'll have to place it onto the RAM. And my friends, congratulations. This process is what is technically referred to as loading. In the interviews, if they ask you, define what is loading, loading refers to the process of taking a copy of the data from the hard disk and placing it onto the RAM. This is what is technically called as loading. That is why, I don't know how many of you have seen it. All of you are telling double click. That is how I'll be able to perform loading in Windows. See, the moment I double click, for a small fraction of a second, you will see a blue color rotating icon on my computer screen. Basically, operating system is telling, hey, Zabi, have patience. I'm taking this data from the hard disk. I'm placing it onto the RAM. Basically, I'm performing loading operation. See, I'll show it. The moment I double click here, please observe this carefully. Immediately, for a very short span of time, you are able to see a rotating icon. See, now, are all of you able to see what data is present in sample3.txt? Yes. Think and answer. If you're able to see this data, who is helping me see this data in my computer as of now? It is nothing but the microprocessor. And microprocessor is connected to the RAM. It is not connected to the CPU. And if I ask you this question, let me ask this question to Kavya Shri. Good. This is the question. Whatever data that you see now, where is this data present as of now? This copy of the data that you're able to see, which copy is this? Is it hard disk copy or RAM copy that you're able to see? Very good. But I told you, see, I use the words very carefully here. I did not say cut paste. I said copy paste. This data that you're able to see here, it is a copy of the data from the hard disk. Because if I just minimize this, see, this data sample 3, it is still present on the hard disk. This is just a copy that is present on the RAM. See, you're able to see it clearly. Now let us say I want to do some changes in this file. Maybe I want to enter my name somewhere here. I would say Sayyid Zabiullah, like this. Now, think and answer. As of now, whatever changes I have made, in which version of this sample 3 have I made this change? On the one that is there on the RAM, not on the hard disk. Just in case I close this, what do you think is going to happen? Will I be able to see this name in the file that is actually stored permanently on the hard disk? 100% it is not going to be present. But all of our operating systems are very latest. The moment I try to close this, operating system thinks Zabi is committing a mistake. So it will first take my confirmation. Hey, look, Zabi, you have made some changes. It is not saved. Now, if I tell don't save, that file is deleted. That means the copy from the RAM is deleted. But now, once again, if I open the one from the hard disk, tell me, do you see my name here? Absolutely not. Now you think an answer. I want to make sure the change that I'm doing on this data, which is present on the hard disk, it should be reflected on the where I'm making on the RAM. It should also be reflected onto the hard disk. Can you think and answer what is that I should be doing? Very good, very good. Basically, what Rasina is trying to tell me is I have to perform the reverse of this operation, boss. Taking a copy of the data from the hard disk and placing it onto the RAM. This is called loading. Now, if you do some changes here, you want these changes to be reflected on the original data that is on the hard disk. Basically, the reverse of loading is what we technically refer to as saving. Our entire life, we were talking about loading and saving, but we didn't actually knew in technical sense what happens exactly within the computer. This is what happens. So, sir, please prove it to us, sir. Of course, I will do it. See, I've done some changes here. This star here in the name indicates it is not yet saved. I will save it. How to save? Of course, today, in the latest operating systems, you have this keyboard shortcuts. Control yes will also save it. Or you go to file, you simply tell save. See, done. Now, if I delete this, let us say now if I close this, do you think it is going to delete it from the hard disk also? No, only the copy from the RAM will be deleted. But no, hard disk is there permanent. If I now open it, as you can see, the changes that we made has been definitely reflected. Am I clear with this, everyone? All of these are very basics, fundamentals about the memory devices, which unfortunately, in fact, the computer science students also lack this basic information. Anyway, sir, it was a great explanation about the memory devices, sir, but we're interested to know more about them. Of course, you are attending my class. How can that not happen? Now, understand this. You have to answer this quickly. Between hard disk and RAM, who do you think is directly connected to CPU? Hey, clearly from my screen, well, you can see it. It is the RAM who is directly connected. That is why your RAM is also referred to as main memory. Sometimes it is also referred to as primary memory. Am I clear so far, everyone? Tell me, what about hard disk? Is hard disk directly connected to microprocessor? No, that is why your hard disk is referred to as the secondary memory device. But think and answer. Let me see how many of you are actually listening to the lecture, or some of you are like, he is speaking something. Our job is to get attendance. Let us just log in into the session. What are we losing? And let us keep playing Call of Duty, PUBG, whatever nonsense things are available on the internet to waste your time and energy. Think and answer. Do you think the hard disk was always secondary memory? Some of you are telling yes. I am asking this question once again. Was the hard disk always termed as a secondary memory device? 100% no. Between 1956 and 1966, how many devices were there? Only one. Hard disk itself was the primary memory device. See, I don't know, you students know, without examples, you will not understand properly. Again, I give the disclaimer, you should take positive messages from my example. I'm not trying to influence you with any information. Let us say a person has married to somebody. First marriage it is. How many wives will be there? Only one. Both primary, second, everything. Now let us say over a period of years, this person went to USA, something happened there. He also married once again. Second wife. But who becomes primary now? I don't have to explain. All of you are smart enough to understand. Anyways, jokes apart. So this is with respect to the RAM and the hard disk. Perfect. Next word, sir. Now, see, something very technically, I'm going to speak about it. Understand this, understand this. Now, do not fight first wife, second wife. First, get a proper job and start your career. Then you can plan all of those things. Concentrate here. Can you store data on the hard disk? Of course, yes. Hey, I've shown it practically also. It is there in the diagram also. Look at this, everyone. Look at this. I appreciate Uday, Bhanu Prasad, all of these, Guru Devi. These students are very prompt response is what I'm able to receive from all of these students. Of course, there are a few others also, just to name a few. Can you store data on the hard disk? Yes. Such a storage location on the hard disk where you will be able to store data. Congratulations. That is what is technically called as a file. Send me this file. I will send you that file. We have been speaking, but we didn't actually know what is a file. Now, see, the definition is also very simple. A file is a storage location on the hard disk where you will be able to store data. Simple. Similarly, can you store data on the RAM? Of course, yes. But that storage location on the RAM is not called as file. This is technically called as a byte. Byte is a storage location on the RAM where you will be able to store the data. Similarly, sir, can we also store data within the microprocessor or CPU? 100% yes. Of course, you can't store GBs of data there. Small amount of data, if you want, you can store it. I don't have to tell you what are the storage locations within your microprocessor are called as. I've spoken about it in one human architecture. Let me see if there is anybody who. Very good, Akash. Anuradha, Kavya, Deepika, Manisha, Yashvita, Rasagna. Good. I'm receiving many other answers here. Vinaya, Jyotirmai. Good. These storage locations within your microprocessor where you'll be able to store the data is what is technically referred to as registers. Good. Is that clear, everyone, so far? Great, sir. Next word, sir. Next word means you please think and answer. Usually for hard disks, what is the memory capacity going to be? It is going to be somewhere between, let us say 128 GB, at least it is supposed to start from. It can go up to 1 TB, 2 TB, 4 TB, 6 TBs, 8 TBs also. So usually, most of the times, we deal with terabytes here, TBs. What about RAMs? RAMs very rarely, I mean, never ever I have seen any RAM which comes in terabytes. Here it is in GBs only. I hope you're able to understand. So clearly, between hard disk and RAM, who is going to have more storage capacity? Hard disk, obviously. Now, since it is going to have more storage capacity, obviously more data is going to be stored. More the volumes of data, organizing the data also becomes extremely important, because once you store it, accessing also should become very easy. That is why to organize the data within your hard disks, you are permitted to create partitions within your hard disk like this. You can create partitions within your hard disk. See, just like how all of you in your home, you will have this wardrobes. Within your wardrobes also, there will be different partitions. a place where all of your casual clothes are kept, a place where all of your formal clothes are kept, a place where all of your blazers are hung, a place where all the socks are kept, a place where all of your ties are going to be kept, a place where all of your maybe jeans clothes are going to be kept. Separate sections are going to be created. Similarly here also, sir, what would happen, sir, if no sections are created? Just imagine your wardrobe where you can't organize only. Can it take hundreds of pairs of clothes? Yes, you can store it. Let us say tomorrow morning there is an interview scheduled. You have to go to the campus with formal clothes. Now I hope all of you are realizing that is where the actual problem would come. So only storing is not important. If you organize and store it, accessing will also become easy. Great, sir. But sir, can you please tell us what are these partitions called as? These partitions are technically called as drives. That is why in your computer also, in your hard disk, it has been divided into many partitions. C drive, D drive, E drive. Why? Organizing the, where is C drive on the hard disk? Where is D drive? It is also on the hard disk, but it has been organized. Even further, they have given you the option to create partitions within these drives also. So see, if you want, you can create partitions within these drives also. Can you tell me what are these partitions within the drives called as? I'm not speaking anything technically here a lot. This is what we have been doing. Good Kirtana, good Mallikarjun, good. These are only technically called as folders. That is what somebody, most of the Linux based users, they also refer to it as directories. Folders, directories, both means the same. I hope all of you have been able to understand. All of these are very fundamentals with respect to the memory devices. Great, sir. Next word, sir. Next word means one last piece of information here between hard disk and RAM, which is the fast executing device, which can support the fast execution of microprocessor. Undoubtedly, RAM. Now, please understand, RAM also cannot cope up with the speed of the microprocessor. Sir, what are you trying to say, sir? Suddenly there is a climax in the story. Yes. See, your hard disk is like bullock cart wheels. RAM is not the Ferrari car mag wheels. It is like maybe to Ferrari car, you have taken Innova car wheels and you have attached it. Will you be able to drive beyond the speed of the bullock cart? Yes. But can you touch the Ferrari car actual speed? It is not possible. Why, sir? Because your microprocessor is a pure processing device. Your RAM primarily, what is its primary responsibility? Storage device. Hence, it is not that fast in execution. That is why what they decided was, let us introduce another memory device between the RAM and the microprocessor like this. A very small storage device. And of course, this is completely clear. Anything that is connected to the microprocessor should obviously be a semiconductor technology device. If not, same problem. Good, Anuradha. Good, Priya. Now, sir, what would be the size of this memory device? Usually, it would range from 8 MB to 32 MB at the max. I hope you're understanding. Very small. Today, if you take one selfie and if you post it on Instagram, that itself is going to take 5 MB. So just imagine maximum. Now, sir, how is this going to be connected, sir? Just because this has come in between RAM and microprocessor, so will this bus connection be eliminated, sir? 100% no. That will be retained as it is. Along with that, a new connection will be established between RAM and this new device, and between this new memory device and the microprocessor like this. That means for the microprocessor to fetch the data from the RAM, there are two routes available, two paths available, directly or through this memory device. Sir, can you please tell us what is this memory device called as, sir? Congratulations. This is what is technically referred to as cache memory. That is what it is referred to as. What is the purpose of the cache memory, sir? Let us say there is one photo in your computer, which again and again you are opening it and seeing it again and again, 100 times. Don't you think the size of the RAM, since it is in GBs, out of GBs of space on the RAM, searching for that one photo might be time consuming for microprocessor. That is why Sir, can I choose to place some data in the cache memory? That is not up to you. It is for the operating system to decide. Let us say the same photo, you're opening it, closing it, opening it, closing it, opening it, closing it 100 times. Automatically, operating system is going to take that photo, it is going to put it on the cache memory. That means what data will be there in the cache memory, sir? Frequently requested data, that is the term that we use, is going to be placed on the cache memory, so that searching for this data in such a small space will be a lot easier and less time consuming than searching it in the RAM. Am I clear with this, everyone? Did all of you understand so far? Why do we have two different types of memory devices? Because we have got 6 expectations. Now, my friends, observe this. I had told you when I was speaking about one human architecture, within a computer, how many units have to be there minimum? Good, Rasagna, Kavya. 4 units. Correct, Vinaya. 4 units have to be there. Input unit, processing unit, memory unit, and the output unit. See, all of these 3, hard disk, RAM, and cache memory, going to be considered as memory unit. This is CPU is your processing unit. So which 2 units are missing here? Input unit and output unit. So see, let me complete the diagram. Let me show those 2 units also here, so that our one human architecture, the previous day, it was very superficial diagram. Today, it is a very detailed diagram. So maybe this is your input unit. This is your output unit. Unit means basically device. Input unit can be keyboard, mouse, basically. And how are they going to be connected? I told you in the one human architecture itself, all of the units are connected to a central unit called as the processing unit. So see, this is connected to the microprocessor. And if any output has to be sent, that also should go through the microprocessor like this. Congratulations, our one human architecture in detail with a lot of depth we have been able to understand through this discussion here. And everything that you see on my screen, all of them are hardware components: hard disk, RAM, cache memory, input unit, processing unit, output unit. But if you only have hardware devices within your computer, it is like a human who is a dead person. For a human heart to function, for a human brain to function, what is needed within a human body? Soul is needed. What is that soul within our computer system that is going to instill life in all of these hardware devices, sir? That soul within your computer system, along with all of these hardware components, you also need a software, and not WhatsApp or Zoom. The most important software component within your computer is the operating system within your computer. This is going to instill life within all of the hardware components within your computer. Is that clear, everyone, so far? Sir, what is the operating system, sir? Don't complicate your understanding. I am going to make the definition simple for you. It is there in the name itself. See, observe this. Operating system is a software that is going to make the system operational. That's all. Operating system is a software that is going to make the system operational. That is why it is considered as the most important software component within a computer. Am I clear with this, everyone? Interface between human and computer. Good. That definition is also appreciated, but that is a textbook definition. You can write it in your exams. But for you to understand what is an operating system, it is a software that is going to make the system operational. Perfect. Am I clear with this, everyone? I know it was a lot of information here. That is why I think it has also taken almost more than an hour, 1 hour, 10 minutes or so it has taken. But I believe this time was worth, because there were a lot of fundamentals, a lot of basics that I have been able to clarify through this. A nice explanation, sir. Thank you so much for that. Right. Perfect. Now see, even in 2023 also, in all of your computers, how many memory devices do you have? In 2023, all of your computers have how many devices? Memory devices. No, it's okay. Cache memory you can ignore. Ignore cache memory. No, some of you are telling 4. I am wondering what is that new memory device. Good. In all of your computers in 2023 also, I don't know about your computers. In my computer, I have got both hard disk also, RAM also. How many memory devices do we have within our computer? 2 memory devices. Just imagine if I had asked this question as a technical interviewer, as a recruiter at the beginning of the session. Why the hell do you have 2 memory devices within your computer at the beginning of the discussion, exactly at 7:13? None of you would have been able to answer to this question. Now you have got solid reasoning. You understand the reason why we have 2 types of memory devices within our computer, because as a computer user, we have got 6 expectations from a memory device. And even in 2023 also, we don't have a single memory device that can satisfy all of these 6 expectations that we have from the storage devices. Tomorrow, if you become a software engineer, if you happen to create such a memory device which can have all of these 6 features taken care, then I will be the first one to remove both hard disk and RAM from my computer. I will embed whatever the new memory device you have invented, that will be installed in my computer. But for that, I'll have to wait, because you have to complete your graduation, you have to clear your placements. Then if you invent the memory device, please do let me know. I hope we are connected on the LinkedIn also. Anyways, I hope all of you have been able to understand hard disk, RAM, what is the meaning of loading, what is the meaning of saving. I repeat those definitions once again. Loading refers to the process of taking a copy of the data from the hard disk and placing it onto the RAM. Saving refers to the process of taking a copy of the data from the RAM and placing it onto the hard disk. File is a storage location on the hard disk. Byte is a storage location on the RAM. Register is a storage location on the microprocessor. Cache memory is a semiconductor technology based memory device that has been introduced between RAM and the microprocessor, whose capacity is going to be very less. It is usually dealt in terms of megabytes, MBs, and it is frequently requested data that is going to be stored within the cache memory. Which device is expensive, which device is less expensive, which device provides more storage capacity, which device provides less storage capacity, everything in detail I have been able to speak about. Is that clear, everyone? Please let me know if there are any doubts pertaining to the memory organization that I've just now spoken. I'm waiting if there are any doubts. No, that's great. If you don't have any doubts, that's great. No, don't try to forcefully induce questions and doubts. If you have understood, that is great. Okay, the attendance link, the feedback and attendance link is also sent in the meeting chat. I have also been speaking continuously for almost 1.5 hours. So let me also just take a small break for 2 to 3 minutes. Meanwhile, please complete the attendance as well as the feedback link. Let's do one thing. Let's take a break for 3 minutes now. Exactly at 8:35. Let us continue with the discussion. Thank you, everyone. Right. Let's continue, everyone. Please get back. I believe the attendance is registered through the Google form link that was shared. Okay. I see some common questions, especially on the YouTube live chat also, that, sir, explain the cache memory once again. That is what many of you are asking. See, always understanding the why factor behind something is important. So first understand, why did we first of all introduce something called as the cache memory? It is because to even more optimize the time that is going to be taken between the microprocessor and the RAM to make the processing even more faster. That is the ultimate purpose of the cache memory, the reason behind why it was introduced. It is a very small memory device. I don't want to get into the nitty-gritties of it. I mean, then slightly from software, we would be deviating towards hardware. In cache memory also, there are 3 levels of cache memory: L1 cache, L2 cache, and L3 cache. I don't want to go in depth. Just understand whatever I've spoken so far. You should know what type of data will be stored in the cache memory. I have also written it on the screen. The frequently requested data is what is going to be present in the cache memory. Am I clear with this, everyone? Okay, another question that I see here is, what is the memory device that we usually have heard of it during our school days? ROM. It is there in the name itself, a read-only memory, ROM. That means you will not be able to store the data, already stored data. That is why whatever data has to be stored on the RAM, it is already pre-decided by the manufacturer itself. And when do we use ROM, sir? Remember this another technical terminology. At the time of booting of your computer system, when your computer system is starting, there are few necessary software applications that should be executed. In fact, it should also trigger the launch of your operating system. All of those programs are going to be pre-installed already on the RAM. Hence, it is going to be executed. Can we store some data, user data on the RAM? It is not possible. Am I clear? Prajyot is telling my voice is not audible. I'm sorry, there is this festival season going on. So there is Ganesha procession that is going on. So the noise is quite too loud. That might be the reason behind. Am I audible, others?
Yes, Sayed, you are audible.
Okay, great, great. Perfect. I think in that case, there is some technical glitch at your end. Please do check. Okay. Right. Now, for this, I have also created a very beautiful presentation. I want all of you to just have a look at it once. And of course, I will not be able to give time for you to copy and draw these diagrams and everything. That you can do it at a later point of time, since anyways, you'll be able to watch the recorded version of this class as well. Of course, it is still yet to be completed. There are a few animations that are pending. It's a huge task creating PPTs. Anyways, so just a quick summary here, everyone. Whenever data has to be processed by the microprocessor, definitely there is a need for the storage device. That is when IBM in 1956. Okay, I think the hard disk element is also there. Let me directly show the final diagram. I think that would be better instead of. Still, the work is slightly pending over here. Just a second. I don't know why the hard disk is missing there. Okay, it's better you see the last final how the diagram is going to look like. It might look like it is too much, but trust me, you have understood everything. Take your time. Few things I want my students to notice here. If you notice it here, I have given the reasoning why this is called as the semiconductor technology device. It is because it is made up of transistors and capacitors. Why microprocessor is called as a semiconductor technology device? This already you guys know it. It is because it is made up of transistors. But your RAM is made up of both transistors as well as capacitors. Now, don't ask me what is a capacitor. All of you have learned about this in your schooling, or at least in 11th and 12th. Basically, they store energy. And I also want all of my students to pay attention to this piece of information at the last. Self-explanatory it is. When you go in this direction, CPU, RAM, and hard disk, both the speed as well as the cost is going to reduce. No, it is going to increase. Correct. No, but speed wouldn't increase. The speed and the cost would reduce, and storage, I think the arrow mark directions are also should be swapped. Let me better delete. No, I think it's correct. CPU is more faster compared to RAM, and obviously it is expensive. Same is the case with hard disk. But if you come in the reverse direction, the storage is going to reduce. Perfect. If you want to take a screenshot or something in your computer systems, you're free to do so. But please make sure wherever you post it on social media, do not forget to give credits to me. I'm just kidding. It's your choice. This is the memory organization of a computer. Are we good so far, everyone? Can we proceed then? Perfect. All of you, please observe this now. Let us go back to the paint screen. Let us quickly erase whatever is on our screen. Next, what are we going to understand, sir? I know that there are two memory devices within our computer, but for you to understand as a programmer, as a software engineer, RAM becomes extremely important here. So I want to discuss something more about RAM here. What is it, if you ask me? Understand this. See, for the sake of an example, I want to consider certain size of the RAM. Maybe, let us say I'll take the size of the RAM in my mobile phone itself. Maybe I want to consider 8 GB of RAM. Now, what does it mean? I want you to understand. So see, let us do the quick math over here. 8 GB. What does it mean? GB stands for gigabytes. I'm sure all of you know. Giga means it is 10 to the power of 9. I'll just show power like this. 10 to the power of 9 bytes. What does it mean, sir? It means 8 followed by 9 zeros. 3, 4, 5, 6, 7, 8, 9 bytes. These many bytes are going to be present in a 8 GB of RAM. Okay, before which I want to show it to you. How does a hard disk and a RAM look like? And there is a interesting fact also there. Just understand this. Let me directly take you to the Chrome screen here. See, I would say IBM hard disk 1956. You will be shocked to know something about this. I'll just go to images. I want all of you to just look at this image over here on the right side. Do you see there are at least some 4 to 5 men who are trying to load something onto a big vehicle like a truck? Friends, what you see on my screen is nothing but the hard disk of 1956. And this is not surprising. What is more surprising is you should read the title of this. What was the size of this hard disk in 1956? If you ask me, it was not some 500 terabytes, at least 1 terabyte. It was a 5 MB of hard disk. This is how huge it used to look like. Now it all makes sense when our school teachers used to tell us in the computer science classes, Back then, the size of a computer, it used to occupy the size of your entire classroom. Have you heard of the statement? Why? Because the individual components of your computer used to be this huge. Luckily, the technology, because of the technology advancement today, I don't know how many of you have seen those pen drives, these SSD cards, terabytes of memory, GBs of memory space. It can just fit in the size of your, it is almost the size of your nail, I can say. But back then, this is how huge it used to look like. I mean, if some of you had the option to click a selfie in 1956 and you want to store that selfie permanently with you, then literally you have to buy this hard disk, because 5 MB is enough for a selfie. Today, you just open your mobile phones and see the size of every single image in your gallery. And wherever you go, literally you have to own a truck. Hey, I want to take that selfie with me. Basically, it is a hard disk, 5 MB. Anyways, sir, today how does a hard disk look like, sir? Let us see if I'll be able to show the hard disk drive images today. See, this is what I told you. You will have these rotatory disks when you open the side panel of the hard disk, and you will have this needle to perform read-write operation. This is how a hard disk is going to look like. Of course, on top you will see this. If you remove this, this is how things are going to look like. Sir, how about a RAM? See, a RAM would look like the green color scale kind of a structure like this. See, these are only your RAMs. It is important to know how things are going to look like. Is it clear, everyone? Perfect, sir. Next word, sir. Let us directly jump to the paint screen. Now, I want to know how many bytes would be there in a 8 GB of RAM. And I have not done any manipulation here. The calculations is directly in front of you. 8 GB, what does it stand for? I have everything. I've shown it here. Sir, what is this number, sir? I don't even know what this number is. I have to also count units, tens, hundreds, thousands, 10,000s, lakhs, 10 lakhs, crores, 10 crores, 100 crores. It is literally 800 crore bytes that are going to be present on your 8 GB of RAM. Sir, how is it even possible, sir? 800 crore bytes in just such a small memory device. That is where your electronic students specialization comes into the picture. Something called as VLSI, very large scale integration. That is where that application of VLSI is nothing but your RAM. Those many hundreds of crores of bytes, it is going to be integrated into such a small piece of memory. Oh, great, sir. That means, sir, how would the RAM look like, sir? Boss, this is how your RAM is going to look like. What is the RAM? It is going to have 800 crore bytes. So see, this is your first byte. See, observe this, observe this. Just a minute. I mean, for me, writing the programs and explaining would be a lot easier, but to give the diagrammatic representation, it is definitely a bit of challenging here. So please bear with me. I have to show you as many bytes as many possible. Only then this topic would be clear. Of course, I mean, it's humanly impossible for me to show 800 crore bytes here. So in between, I'm just going to put some dashes over here indicating there are many, many bytes. Perfect. Next word, sir. Next word means, now please understand, every byte on the RAM, the operating system is going to identify every single byte on the RAM with a unique number. What would be the that unique number using which every byte is going to be identified? It is technically called as the address of the byte, the memory location, the reference of the memory here. What would be the address of the first byte, sir? For you, it is the first byte. But friends, always remember, in computer science, in programming, numbers don't start from 1. Numbers actually start from 0. So see, this is the 0th byte. A minute. This is your first byte. This is your second byte. Similarly, this is your third byte. This is your fourth byte. This is your fifth byte. Similarly, sixth byte. This might be your seventh byte. This could be your eighth byte. I hope all of you are understanding. Every single byte will have a certain address. Can you tell me what would be the address of the last byte if there are 800 crore bytes? Please be careful. You started from 0. That means the address of the last byte would be 800 crore minus 1, which is nothing but 7 followed by 9 nines. This is going to be the address of the last byte. Is that clear, everyone? Somewhere in between, let us say the address of this byte is...
Sorry for interruption. Your screen is not visible. Actually, it is freezed. You're writing something, right?
Yep. Oh, is it?
Yeah.
Thank you, Chandana. I was not even able to see the chat from the students. Okay. Oh, I'm so sorry about it. I thought the screen was visible. Anyways, I think I didn't really draw any complicated diagram, so things should be quite clear for all of you. I will do one thing if I can undo things and reload for you once again. See, like I said, to find out how many bytes would be there in a 8 GB of RAM, all of the calculations are done. I hope till here all of you have followed it. Now see, I'm going to show those bytes here. This is the first byte, second byte. Like this, there are going to be bytes on this RAM. And like I said, every byte is going to have a certain address. So see, addresses are also being shown here. This is the address of the last byte. That is all I have spoken about it. Now see, maybe the address of this byte somewhere in between, I'm assuming it is going to be 2. Basically, it should be a 10-digit number where the first digit should be between 0 to 7. I hope you're understanding the math behind. So maybe let us say some random number is what I'm going to write. This is some 264th crore is the address of this particular byte. Great, sir. Next word, sir. Next word means we also know that who is going to process the data from the RAM. It is the microprocessor, because both of them are also connected via the bus connection. Now, let us say in my program, if in case I happen to store some data, let us say the data happens to be 45. So maybe whenever wherever the operating system is going to find vacant space, immediately it is going to be reserved and the data is going to be stored. So please do not get confused. This 0, 3, 6, all of this, whatever you see, these are all referred to as addresses, memory references. All of this is address. But what about this 45? Hey, 45 is not an address here. This 45 here happens to be the actual data. This is the data that we have here. Am I clear with this, everyone? Now think and answer. If in case your microprocessor now is interested in accessing this data 45, where is it actually present? 264th crore change. That is where the data is present. Now, how is that microprocessor is going to access this data, sir? Is it going to go sequentially? First, check, go to the 0th byte and check, is the data present? No. Is the data present? No. Is the data present? No. Is the data present? I hope you're understanding. This would be a very inefficient way of accessing the data. Luckily, this is not how microprocessor is going to access this piece of data 45. Why, sir? If it was accessing the data starting from the 0th byte going sequentially, my friends, in that case, your RAM would not have been called as RAM. It would have been called as SAM, sequential access memory. I'm not trying to make fun of anything here. Literally, it would have been called as SAM. Your friends would have asked you, how many GBs of SAM do you have in your mobile phone? Very unfortunate for people whose actual name would be Sam. They would be confused. Anyways, I'm not, like I said, I'm not trying to literally crack a joke at all here. There is a reason why RAM is called as RAM, why it is not called as SAM. What is the meaning of RAM, sir? Random access memory. The microprocessor can randomly access any piece of data from this memory device. How, sir? The credits have to be given to the something called as the addresses of these memory locations. Let us say someday, if I happen to maybe visit the state of Maharashtra, I would be interested in visiting one of my students' place also. Maybe he lives somewhere in Borivali. I am also sure, okay, this is the locality where he stays. Am I going to go through every single house in that particular city, in that particular locality? 100% no. Can I directly go to exactly the person's house, whose house I'm interested in visiting? Yes. How is that possible? Because all of our houses have been given a unique address. It is through that address I will be able to reach there. Same is the concept that is being implied here also. Since every single byte on the RAM is going to be given a unique address, your microprocessor don't really have to waste the time going sequentially. Directly, randomly, it can go through this particular address and it can penetrate inside this byte. It can access the data. It can do whatever manipulations it want to do on that particular piece of data. Am I clear with this, everyone? Now, finally coming to the actual part of this discussion. If in case anybody would ask you, what is the definition of RAM? This should be your answer. Your answer should not be primary memory, random access memory. Nobody is asking abbreviation. Main memory, semiconductor technology based device. I am asking the definition. What is the definition, sir? This is the definition. RAM is a collection of bytes. That is what you should be telling. But for me to justify this statement, I had to explain all of this, or else definitely wouldn't be convinced. Sir, what is this, sir? Collection of bytes. Hence, in my upcoming lectures, suddenly I would ask you this question. Can you tell me the definition of RAM? This should be your answer. RAM is nothing but collection of bytes. 8 GB of RAM will have approximately 800 crore bytes. 4 GB of RAM will have approximately 400 crore bytes. Is that clear, everyone? Did all of you understand so far? Great. Like I said, between hard disk and RAM, RAM is important for us when we start programming. Now, whenever we speak about RAM, also a quick piece of information to all of you. I want to complete it in just a minute. There are two types of RAMs actually. There is something called as the DRAM, dynamic random access memory. There is also something called as SRAM, static random access memory. What is the difference, sir? Now understand, for you to understand the difference, what you should do is, look at here, everyone. I want to consider this one byte and I want to go inside this one byte. So see, I'll copy this, I'll paste it over here. And this one byte is what? I want to go into details. This one byte is actually further divided into 8 different partitions. See, there are 8 partitions in this one byte. I'm just drawing rough diagrams because I don't want to waste neither your time nor my time here. I don't know about your time, but my time is quite precious. See, this one byte is divided into 8 different slots, 8 different partitions. Sir, what is that each partition going to be called as? Tell me, what is that each partition going to be called as? Good. That is what is called as a bit. That all of you will know, but this you will not know it. That is why you should attend the ExcelR training program. Why is it called as a bit? Who can explain to me? I know. A byte is divided into 8 slots, 8 partitions. That is called as a bit. But I want the rationale behind. Why is it called as a bit? Single number. Okay. It's a part of byte. I know that. I'm asking why is it called as a bit? Shrikant, very close. Good, Akash. Yog Shri. Okay, good. Let us not waste the time here. Good, Priya. Observe this, everyone. This byte, it is an acronym for this technical term. It is nothing but binary digit. Because in your bit, what you will be able to store in each of these bits is only zeros or ones. So see, either you will be able to store a 1 or you will be able to store a 0 in each of these bits. See, you're able to see. So in total, how many zeros and ones together you will be able to hold in 1 byte? 8. That's all. That means in each bit, technically speaking, on the RAM, what is the only data that will be stored that is going to be permitted? Zeros and ones, binary data. Since this location is going to be holding a single binary digit, what they have done is, from the word binary, they have taken the letter B. From the word digit, they have taken the last 2 letters. What does it form? Good. That is why it is going to be referred to as bit. Am I clear with this, everyone? Remember this fact, bit is an acronym for binary digit. That means each bit can either hold a 0 or it can hold a 1. Is that clear, everyone? Now comes the bigger question, the difference between DRAM and SRAM. How you are going to manufacture this 1 bit, that is going to determine whether it will be called as DRAM or SRAM. What do you mean to say, sir? In your DRAM, you're going to make use of transistors and capacitors. For what, sir? To manufacture that 1 bit. But in case of SRAM, you're going to use only transistors. Then it is going to be treated as SRAM. So very simple. If tomorrow, let us say there is a student here called as, what was his name? Akash. If Akash, when he is going to sit to manufacture that 1 bit within the RAM, if he is going to use both transistors and capacitors, then it is going to be classified as dynamic RAM. If he is going to use only transistors, then it is going to be classified as static RAM. Am I clear? Sir, can you give example where in my computer I will see DRAM, where in my computer I will see SRAM? Do you remember today itself I was speaking, there is something called as cache memory? Good, congratulations. Your cache memory is made up of SRAM. It is nothing but SRAM. Sir, where do we see dynamic RAM, sir? The actual RAM that you see in your computer, basically the main memory within your computer, that is nothing but the dynamic RAM. Am I clear with this, everyone? This is also a lot of information, just a bit about what we refer to as the random access memory, your primary memory within your computer. Is that clear, everyone? All right, then. For after this, I have to start with a new topic, but it's already past 9, so I don't want to start something and then stop abruptly in between and continue tomorrow. Let it be a seamless flow, just like how we understood the memory organization today. So, anyways, I would be available for another 5 more minutes. If in if in case you have any queries, any doubts for me, please feel free to ask. CTD. I don't know how to pronounce your name. I'm sorry if I'm pronouncing it wrong. I'm just not understanding the question correctly. Can you please rephrase it? Surprise quick quiz. I didn't say it would be on Monday. Anywhere in between this week, the quiz would be considered. Cost of cache memory. Not really sure, Bhanu Prasad. You can Google it. Just a number. Sneha, cache memory and register. No, these are 2 different things. Registers are small storage locations within the processor, but your cache memory is a separate memory component. It is. Priya, it is already started. All of this is part of it. Krishna, you'll have to wait because all of these are prerequisites. Chandana, for all of that, the record would be maintained in the form of a table. So all of that information will be there with the computer. Great session, sir. Thank you so much, Prajot. Thank you so much, Kirtana. Undoubtedly, Kavya, it is going to be registers. Today's session was amazing and very crystal clear explanation about the basics. I'm getting more knowledge from the session. Thank you so much, sir. You're most welcome, Gurdevi. No. Registers don't contain frequently requested data. I have never made that statement about registers. Srishti, just a minute. I'll share the LinkedIn account, but before which I want to see if there are any questions. Kalyani, let things be very clear and transparent. You can't learn entire Java in 30 hours. But how much ever Java, I don't know. I've not really planned as to I'll be able to teach till this particular topic. But how much ever Java, even if it is going to be on the last day, for you to understand that crystal clear without any loopholes in your understanding, all of these prerequisites are needed. Thank you so much, Nayan. Thank you, Jamila. Thank you, Priya. Okay. And the attendance in the feedback link is once again posted in the meeting chat. Please have a look at it. You're most welcome, everyone. Just if there are any questions in the YouTube also, just a second. The attendance in the feedback link is already posted. Just scroll on top and you'll be able to find it. Thank you, Roshni. Thank you, Shana Fatima. No, Akash, I didn't get testing Java. I'm not sure what you're trying to ask. No, see, I have told it previously also. You'll easily be able to find anybody on LinkedIn. Okay. That's the link that I have shared. You can just copy it and paste it on in the URL section, the address bar of your browsers. You'll be able to navigate to the profile. Right then, thank you so much, everyone. It was a very exhausting session for me because there was a lot of information I had to continuously keep speaking. But nonetheless, unless and until my students are going to understand, I don't have any problem speaking for another 2 hours also continuously. Thank you so much, everyone. And I hope it was a fruitful session once again today. Definitely your knowledge levels should have increased by this time. The amount of time that you're investing in these sessions, it is quite difficult to know its value unless and until you complete your graduation, then shed some money and then take up the training. Then the same knowledge you will value it 100 times more. But I hope I have been able to change that mindset of my students in the first session itself. Right. Perfect. Then if you people don't have any questions for me, any doubts, you can leave for the day. Thank you so much for attending. Take care of yourself, take care of your family members. We shall get connected tomorrow sharp at 7 o'clock. And if you have any doubts, please, I would still stay connected for 2 more minutes. Put it in the chat section. And again, I'm telling you, you're all going to be becoming software engineers. So do not try to get too much into the hardware level details, though I might be able to explain, but it is unnecessary and it might also create unnecessary questions and doubts. So nowhere I'm trying to discourage asking doubts, but whatever I've spoken, trust me, that itself is more. I mean, even if somebody is working as a software developer in the industry for 3 years or 4 years also, those experienced individuals themselves might not have this amount of knowledge. You are anyways planning to enter into the industry. So according to me, this is more than enough. Are you again taking the webinars on different topics, sir? Gurudevi, that's the plan in the future. I mean, you guys would anyways be kept informed about it. As of now, we are still yet to decide. Where can I find the recorded sessions? On the LMS, Tina. RAM doesn't approach Chitidi. It is the microprocessor. It already knows the address that we want. A separate table is going to be maintained. Any other questions, people? Make sure nobody is lazy enough here to create your LinkedIn profile. Please do create it at the earliest. The more you're going to delay it, the more you're going to regret it. All right, then. Thank you so much, everyone. I'm not getting any responses in the chat, and I was not able to see the YouTube live chat. I'll have to open it in another device. Of course, Krishna sir, it is going to help everyone. I don't know what is your domain, what is your specialization, but I mean, it is up to you to decide whether this information would be helpful for you or not. Sure, Shana Fatima will accept your request. Done. All right, everyone. Thank you so much. Have a great dinner and great sleep, and let's get connected tomorrow evening at the same time, 7 o'clock. Thank you, everyone.
Yeah, thank you, Syed sir. Wonderful session we heard. And guys, do you have any queries? Please let me know in the chat box. I'm sharing again the attendance link in the chat box. Whoever missed the attendance, please paste the attendance. I think there is no queries for me. I'm leaving the session. Okay, guys, good night. We'll meet you on the same time tomorrow.